In this video, I will start with chapter 14, that is Semiconductor Electronics, Materials, Devices and Simple Circuits. Now the first thing that we have to understand in this chapter is a concept of energy band. What is it? Energy band. Alright, now what is an energy band? Okay, so let me try to explain to you the meaning and the concept of energy band. Now to understand this, let us consider a single atom. Okay, we imagine this to be a sodium atom, let's say. Alright, so let's say this is sodium. Okay, and sodium atom, we have the electrons which are orbiting in different energy levels and in different orbitals. Yes or no? So we have the two electrons in this level here. Let's say those two electrons. Then we have 4 electrons out here. Sorry, not 4 electrons, 8 electrons out there. 5, 6, 7, 8. And then we have the last electron, right? Because the number of electrons in sodium is 11. Okay, and the electronic configuration of sodium having 11 electrons is what? Is 1s2, 2s2, 2p6, 3s1. Okay, so this is how the electrons are arranged in the different orbitals of the sodium atom. Okay, now let us draw the energy level and show how where these electrons occupy. Okay, which levels or which orbitals the electrons, the different electrons of sodium occupy. All right, so we have these two electrons, they will occupy the 1s orbital. All right, and how are they arranged? In this way. Got it? So we also have the 2s orbital. Let me draw this orbital. So this is the 2s orbital, and in the 2s orbital also we have the 2 electrons. Let's say these are the 2 electrons. Okay, one is spin up and another is spin down. And then we have the 2p orbital. 2p orbital is, let's say, here. And how many electrons are there in the 2p orbital? There are 6 electrons. So we have 2 electrons, 4 electrons, 6 electrons. Okay, and lastly we have the 3s orbital. Okay, and how many electrons are there in the 3s orbital? There is just 1 electron. Okay, so this is 2p and this is 3s. Got it? And this is nothing but the energy level of the sodium atom when there is just 1 atom. Got it? Now let us consider the case in which 2 sodium atoms come very close to each other so as to form a sodium molecule. Okay, now how will the energy level of that combination, of that system, look like? Let's say now we have 2 sodium, let's say this is 1 sodium atom. Okay, 1 sodium atom and another sodium atom which is very close to each other so as to form some molecule, let's say. All right, now what will be the energy level? Okay, how will the electrons of this system be arranged now? All right, so in this case we don't consider the atomic orbital anymore, we consider it a molecular orbital. All right, so let me just draw very quickly the energy levels. So what will happen here? So for the first sodium atom, the 1s orbital, there will be 2 electrons. Okay, what about the second? The second sodium atom also will have 1s orbital, yes or no? So that 1s orbital will be something like this. Okay, so this upper level here is that of the second sodium atom. So the 1s electrons of the second sodium atom are arranged like this. So you see here in the 1s orbital we have two levels. Why two levels? Because of the 1s orbitals coming from the two sodium atoms. Understand? And similarly we have the 2s. So this will be one for the first sodium and another. So this will be 2s. In the 2s, let me write again the electronic configuration. So this is 1s2, 2s2, 2p6 and 3s1. So again here the 2s will have two electrons coming from the first sodium. Okay, and the other two electrons coming from the second sodium like this, and then we have the 2p, this is 2p orbital, and the 2p there are 6 electrons coming from the first sodium, another 6 electrons coming from the second sodium, and lastly we have the 3s orbital. So you have the one electron coming from the first sodium and the other electron coming from the second sodium. So like this, you can see here that if you have just one atom, let me show you, where is it? Is it here? Yes, if you have just one atom, sodium atom, then you have just one levels out here. Got it? And if you have two atoms which are coming very close, then you get two levels out here, okay, in each orbitals. You get the idea, right? So if you have three, let's say if there are 3 sodium atoms, okay, which are very close to one another sodium, then in that case there will be one more level somewhere here, okay, like this. Got it? So I'm not going to draw all these. Okay, let me draw for this one, then here there will be like this and another one like this. So you got the idea here. So if there are more sodium atoms, then what will happen? There will be more levels out here, yes or no? Yes. 2 levels, 3 levels. If I have a sodium, a solid, let's say a solid, okay, which is made up of a sodium, all right, a sodium, not just a molecule. Now we have a sodium material, sodium solid. Let's say this solid material here is sodium. Then in that case, how many atoms are there inside? There are many atoms, yes or no? Many atoms. Got it? Innumerable amount of atoms. So here also the energy levels will increase. All right, and those energy levels will become very close to each other. Okay, they become very close to each other, that it looks somewhat like this. All right, so you can see that the levels are very close to each other, that you cannot differentiate between the levels out here. Got it? So now this is not called an energy level anymore. This is called an energy band. Is that clear here? So the energy band. So that is where the concept of energy band comes. So this collection of closely spaced levels, this is called an energy band. Okay, so now let's say we have a solid material, let's say a block of metal. Got it? Okay, now this block of metal, there are atoms inside which are arranged in the specific positions. Okay, you have the atoms like this, okay, forming the lattice of the material. Got it? I'm not going to draw the electrons. All right, so these small circles, these are the atoms. All right, now we also know that because this is metal, a metal has got free electrons, yes or no? So these free electrons, they are able to roam in the body of the metal. Okay, they have they gained energy from the surrounding and they get detached. They come out from the atoms of the metal and they are now called free electrons. They are free to roam here and there. And if you apply an electric field, if you apply a potential difference across the ends of the metal, then what will happen to these electrons? They will drift to one end, from one end to the other end of the metal. Got it? Now these electrons, since they are able to move and because they acquire energy from the surrounding, they are at comparatively higher energy level compared to those electrons which are still trapped inside of the atoms. Are we clear here? So do you agree or not that the energy of these electrons, you see, these electrons are called what? Are called the free electrons. Okay, let me write down here. Free electrons. Got it? And don't you agree or not that these are the ones that take part in the conduction of current? They take part in what? In the conduction of current. Got it? And because they are free, how are they free? First of all, why are they able to free themselves from the atoms? Because they absorb energy from the surrounding. Okay, they detach. All right, they are the ones that are situated very far from the nucleus. Okay, so they get detached easily. And when you apply electric field, they take part, or they are responsible for the flow of current inside of the metal. So in that way, we can call them as conduction electrons. Okay, and the energy of these electrons is quite high. So in the energy level diagram, these electrons, they occupy a high energy level. All right, so this level is called the conduction band. Okay, so what is a conduction band? Basically, it is the range of energy. It is the range of energy possessed by the conduction electrons of a solid material or of any material. Is it clear here? So these electrons, some of them will have, among themselves also, some of them will have smaller energy, some of them will have higher energy. So the ones that have high energy will occupy, let's say, the upper levels. The one that have the smaller energy, let's say, will occupy the lower levels like this. And then you have the mid levels like that. Got it? So this is called what? The conduction band. Why is it called a conduction band? Because it is the range of energies possessed by the conduction electrons. Got it? What are conduction electrons? They are the free electrons which are capable of, which causes the current to flow, to be conducted in the metal. Understand? Now what about those electrons which are still trapped inside of the atoms? Okay, there are still electrons trapped inside, yes or no? So those electrons are called valence electrons. Okay, and because they are still trapped, they will lie or occupy a lower energy level. Okay, a lower energy level. Something like this. All right. So this range of energy occupied by those electrons which are still trapped inside of the atoms of the metal, this is called the valence band. All right. And in the energy leveled diagram, the valence band is situated below the conduction band, and there is a gap in between the conduction band and the valence band. This is known as the energy gap, or sometimes it is called the forbidden gap. Okay, why is it called forbidden gap? Because the electrons cannot occupy this level. Is that clear here? So we have two very important energy bands: the conduction band, which belong to the conduction electrons, and the valence bands, which belong to those electrons which are still trapped inside of the atoms. And between or the gap between the lowest level of conduction band and the highest level of valence band, that is called the energy gap. And this is a very important thing that we should consider, because depending on the energy gap, the materials are classed into different categories. Okay, so let us define and look at these energy bands one by one. So the first one is the valence band. In the energy band diagram, the valence band is the lower band belonging to valence electrons. This band may be partially or completely filled with electrons. This band is never empty, so that means always it is filled with electrons. The electrons from this band do not contribute to the electric current when electric field is applied. Okay, so that is the first energy band. The second one is the conduction band. The conduction band is the upper band in the energy level diagram. This band is filled by the conduction electrons. You remember what are those conduction electrons? They are the electrons which take part in the conduction of current, right? They are also called free electrons, okay? And it is at a higher energy level. Why? Because those free electrons have higher energies compared to those electrons which are still trapped inside of the atoms. At 0 Kelvin, no electrons can occupy this band and it becomes completely empty. Okay, that is one thing to be remembered. At 0 Kelvin, no electrons can occupy this band. Why? Because at 0 Kelvin, the electrons, the outermost electrons, do not get energy from the surrounding to be able to free themselves from the atoms and become free electrons. So in that case, there are no free electrons in the material. Okay, and because of that, there is no conduction electron. So this band becomes completely empty at 0 Kelvin. At room temperature, however, due to the heat or the heat energy that the material absorbs from the surrounding, those electrons gets freed. So it becomes partially filled with electrons. And the last one is called the energy gap. Like I told you, the separation between the highest level of the valence band and the lowest level of the conduction band is called energy gap. This band is completely empty, just like in atoms, right? In atoms you have the nucleus, then you have the shells or the energy levels, okay? So the electrons can be only here. All right, can be only here. Can the electrons be here? Can the electrons be here? No, the electrons cannot be there. Okay, they are forbidden to be here, right? So similarly, that band which is what is it? It is the separation between the highest level of the valence band and the lowest level of the conduction band. All right, so there is no electron here. All right, so that is why it is also called the forbidden band or the forbidden gap. Okay, so those are the energy bands, and this is the concept of energy band. Okay, I urge you to listen or to view this video nicely until this concept is clear. Thank you.